Okay, good afternoon to everybody. In last lecture, we have studied the introduction part of this subject. Okay, good afternoon to everybody. In last session, we have studied the importance of this subject, Unix operating system in your syllabus. What is a central idea of that subject? Then what is objective outcomes and prerequisite of this subject? Then we have started a chapter first, introduction. In that we have taken a first point as a history. So there are several reasons have been suggested for the popularity and success of Unix operating system. So system is written in high level language, making it easy to read, understand, change and move to other machines. Dennis Rich estimate that the first system in C was in 20 to 40% larger and slower because it was not written in assembly language. C language is middle level language and assembly language is high level language. But the advantage of using this high level language for outweigh the disadvantages. Then second advantage or popularity for the success of Unix operating system is it is a simpler user interface that has the power to provide services that users want. It provides primary, that is primitive, that permit complex programs to be built from simpler programs. It uses the hierarchical file system that allows easy maintenance and efficient implementation. It uses a consistent format for files, byte streams, and making application programs easier to write. It provides simple, consistent interface to peripheral devices. It is multi-user, multi-process system. Each user can execute several processes simultaneously. It hides the machine architecture from the user, making it easier to write programs that run on different hardware implementation. Then this is system architecture of Unix operating system. See the architecture carefully. This is the architecture of Unix operating system. In this operating system, central part is hardware, then the kernel, then different commands, nrop, sh, who, a dot out, date, wc, grep, ed, vi. Then these are the application programs, and the compiler construction regarding commands are cpp, comp, as, id. Okay, in this architecture, the kernel is interface between different commands and hardware. Different commands such as who command is used to show who is currently logged in. A dot out command, which is used to execute a C language program. Date command is used to show current day, date, time as per Indian Standard Time and year. Then a WC command, that is word count command, how many words, how many lines, how many words and how many characters in a particular file. For that WC command is used. Then grep command, then ed, then vi editor. Vi editor is used to create a file. Similarly, grep command also is used to create file. Then cpp, comp, as, ld, these are commands for the compiler constructions. So all these commands which operates by the applications programs such as a shell script program. Your chapter number 8, last chapter is on shell script programming. And then all users, this is the architecture. In this architecture, hardware is core or central part of this architecture, and kernel is interface between hardware and different commands, or in general kernel is interface between hardware and user. Okay, this is the architecture. We will see the architecture explanation. This figure shows the high level architecture of Unix operating system. The hardware at the center of the diagram, which provides operating system with different basic services. The operating system interacts directly with the hardware, providing common services to program and insulating them from hardware peculiarity. From the point of view of the system, or viewing the system as a set of layers, the operating system is commonly called as system kernel. Of this operating system or Unix operating system is commonly known as a system kernel. What is the definition of operating system? In general, operating system is interface between hardware and user. Similarly, here a definition of kernel or system kernel is interface between hardware and user, or different application programs or different commands. Kernel is interface between hardware and different commands, or kernel is interface between hardware and different application programs, or in general kernel is interface between hardware and user. So programs such as shell script by using editors ed or vi editors. So these are the outlines editors. This is grep, vi editor, ed editor and grep editor. These are three editors. Shown outer layer interact with kernel by invoking a well-defined set of system calls which instruct the kernel to various operations for the calling programs and exchange data between kernel and the program. Several different programs as shown in figure. These are program, that is application program, or different commands such as who, a.out, date, calendar, then pwd. These are the commands or standard programs. system configurations and known as commands, but private users may also exist in the layer indicated by the program whose name is a.out. This command is used for executing the C program, a standard name executed files produced by the C compiler. The other application programs can build the top of lower level programs, hence existence of the outermost layer in the figure. Then many applications, subsystems and programs that provide high level view of the system, such as a shell editors, that is source code control system, SCCS, source code control system, document preparation packages have generally become synonymous with the name Unix system. However, they all use lower level services ultimately provided by kernel, and they avail themselves of these services via set of system calls. So there are about 64 system calls in system 5. There are totally nearly about 64 system calls in system 5, out of which 32 are used frequently, and they have simple options to make them easy to use but provide the user with a lot of power. A set of system calls and internal algorithms that implement them form the body of kernel, and study of the Unix operating system analysis of the system calls and their interactions with one another. In short, the kernel provides services upon which all application programs in Unix system rely or plays important role and defines those services. Okay, this is the system architecture of the Unix operating system, and this architecture consists of at the center hardware, then kernel, then different commands, and then other application programs. So here kernel is interface between hardware and other application programs or commands or users. In general, there are 64 system calls. Out of them, 32 randomly or frequently used. So these system calls or commands generally sh, this sh for shell script command. There are three types of shell script commands: shish, corn shell, born shell, c shell, bash shell. Total four types of shell script commands: corn shell, born shell or b shell, c shell. Corn shell means k shell, then c shell. Born shell means b shell, and bash. Then who command is used to see who is currently login. Then a.out is used to execute C language program. Date command is used to show current date time. Then wc command is used to check how many lines, how many words, and how many characters in a particular file. Then vi, ed, and these are the grep. These are the editors. Then cpp, compare, then as, then ld. These are the commands regarding the compiler constructions. Then next part is user perspective. User perspective, it consists of 3 points: the file system, processing environment, and building block primitives. So this file system is characterized by, there are 6 characteristics of this file system. So the file system in Unix may be, or it should be, a hierarchical structure. It consists consistent treatment of file data, the ability to create and delete files, a dynamic growth of files, the protection of file data, then the treatment of peripheral devices such as terminals, different terminals like printer, then mouse, keyboard. So treatment of peripheral devices as files, it considered as a file. So the file system in Unix may consist of hierarchical structure, consistent treatment of file data, ability to create, delete and create files, delete and create file, or create and delete files, a dynamic growth of files, protection of data. So file have protections such type as a read, a write, or execute. There are 3 types of groups: owner, then group owner, and other. So each type of file have 3 types of permissions: read only, write only, and execute only. So read, write, execute, these permissions we will see at the time of practical. Then growth of file is randomly, then protection of data, then treatment of peripheral devices. This is a file structure. See the figure carefully. See this figure. In this figure is this file system is organized as a tree with a root, single root node called as a root of that file denoted by slash, and every non-leaf node of the file system structure is a directory. Here bin means binary directory, etc is also directory, user is directory. This is non leaf node. Unix is leaf node. Then device is also directory. Then in binary file or in file system 1, there are again 2 files, mjb, mauri. Then in binary file system there are 3 types of files: sh, date, who. Then etc file is contains password. User contains 2 types of files: source, binary. In source again there is a cmd file. In cmd again there are 2 files: date and who, date.c and who.c. Then unix, this is terminal. Then device files, that is a tty or text to voice and voice to text. Tty means text to voice and voice to text. File number 00 and tty01. So this is the structure of file system structure. In there are 6 operations. We can create and delete the files. Then it have protection in case of read, write, and execute. Then it can it have growth randomly or dynamic growth of the file system. Okay, it have a central root node known as a root denoted by slash, and every non-leaf file system structure is directory of file. Non-leaf node, these are sh, date, who, these are the leaf nodes. Then above above this is a directory, that is a binary, is a directory. fs1 file system 1 is also directory, etc. This is also directory. User is also directory, and device is also directory. Unix is not a directory, it is a file in this file system structure. Okay, so all the leaf nodes of the tree, either directory, regular files, or special device files. All the leaf nodes of the tree are either directory, regular files, or special device files. So name of file is given by a path and describes how to locate in the system file directory. Name of file are denoted by a particular path so that we can find the file, particular file. Okay, a path name is a sequence of component name separated by slash characters. A path name is a sequence of component names separated by slash characters, and a component is a sequence of characters that designates file name that is uniquely containing the previous directory component. See here, path name. Suppose I want to find file password. Suppose I want to file password file, then slash, this slash indicates as a root, then etc directory, first it root, then etc directory. Now etc is root for the password, so etc is root, or etc is a parent node for the password leaf node. Similarly, I want to find who file. Similarly, I want to find who file. So there is a root, then go to binary file, then who. So a full path name starts with slash character and specifies the file that can be found by starting file and the system root and traversing the file tree, following the branches of that lead to successive component names of the path name. See, suppose I want to find the file date.c. I want to find the file date.c, then first root, then directory user slash source slash command slash date.c. Suppose I want to find the file date.c, then first slash, then user slash source slash cmd slash date.c. But you can't write like this slash user slash source slash date.c. Okay. So the file system, the programs in Unix system have no knowledge of internal format of the in which kernel stores file data. Programs in Unix system have no knowledge of the internal format in which kernel stores file data, treating data as unformatted stream of bytes. Programs may interpret the byte stream as they wish, but the interpretation has no bearing on how the operating system stores the data. So the syntax of accessing data in a file. So the syntax of accessing data in a file is defined by system and it is identical for all programs. But the semantics of data are imposed by the programs. So directories are like a regular files in respect. So system treats data in directory as a byte stream, but data contains the name of files and directory is predictable format. So ls command is used, that is list the names and attributes of the files. If the file starts with a D, if the files starts with the D, then it is a directory. And if the file starts with the dash, then it is a file. And each and every file have permissions to read, write, and execute. Whenever you type the command ls, then sum of file shows drwx, then rwx or r dash x. This indicates that the d is directory, then first rwx is user, then next rdx is rwx is group, and next remaining rwx is others. There are total 10 characters. First character if is D, then it is a directory. Then next three character is RWX. R for read, W for write, and X for execute. Sometimes these characters are replaced by dash. That means this dash indicates, suppose instead of R they have written as a dash, that means it does not have read permission. So first character is D, then next three characters R, W, X, that is a read, a write, and execute. These first three characters, that is 2 to 4, these characters for the user. Then 5, 6, 7 characters, these three RWX for group, and remaining 3, that is 8, 9, 10 character RWX for others. Whenever practical will be, then you will understand. So access permission can be set independently to control read, write, and execute permission for the classes of user, file owner, file group, and everyone else, that is other. So user may create files if directory access permission allow it, and the newly created files are leaf nodes of file system directory structure. Whenever you have created any file, then it is a leaf node of a particular directory structure. So to the user, Unix system treats devices as if there were files. devices designated by special device files. Devices designated by special device files occupy node positions in the file system directory structure. So see the structure directory file system structure carefully once again. See in this file system structure, this is the root. This is a file system 1. This contains two files mjb, mori. Then binary file system, that is binary directory bind, which contains sh, date and foo file. Then etc, which contain password, then user. This directory contains a source and again binary file. This binary and this binary is different. This is directly connected to the root and this binary is connected to root through user. Then source, for source there is a command node, and for this command node there are two leaf nodes det.c. This is a program in C language, and who.c, this is also program. Then device file, that is tty device, tty 00, this is one device, and tty is 01 is another device. Only tt is a device which converts a text to voice and voice to text, that is a tt device. Okay, so device designated by special device files occupy node positions in the file system and directory structure. Programs access devices with same syntax they use when accessing regular files. Semantics of reading and writing devices are to large degree of same reading and writing regular files. Devices are protected in the same way as regular files are protected by proper setting of their file or access permission, because device names look like name of regular files, and because of same operations work for devices and regular files, most programs do not have to know internally the types of files they manipulate. Then next part is processing environment. So for the processing environment, there is a program, and a program is executable file, and process is instance of that program in execution. Process is a part of a program. Process is a part of program, and program is executable file, and process is instance of program in execution. Instance of program in execution. So many processes can execute simultaneously, and that's why Unix operating system is sometimes called as multi-programming or multitasking with no logical limit. to their number, and many instances of programs such as copy, they exist simultaneously in the system. So many processes executes simultaneously. That's why the Unix operating system is known as multitasking or multi-programming operating system with no logical limit to the number and many instances of programs. Many instances of program means that is processes can exist simultaneously in the system. Various system calls or various commands allow process to create a new process, terminate process, and synchronize the stages of process execution and control reaction to various events in operating system. In last semester you studied that is process state a transition diagram, dormant, new, ready, running, suspended, that is the creation of new process, termination of process, that is execution of process, then process execution, process reaction to various events such as suspended, then ready to join. Some processes are also in queue. So subject to their use of system calls, process execute independently of each other. So in shell script or in Unix operating system, shell commands or shell searches for commands in a given sequence of directories that are changeable by user request as per innovation or invocation of the shell. Changeable by user request, that means change mode, then change mode, chmod, this is a shell command, or chown, chw chown, that is chown म्हणजे that is change owner, that is owner, group owner, or other. This is a change as per a requirement or request of innovation of shell. The shell usually executes a command synchronously, waiting for command to terminate before reading the next command line. However, it also allows asynchronous execution where it reads the next command line and executes without waiting for prior command to terminate. There are synchronous execution and asynchronous execution in shell commands. Whenever there is a synchronous execution command, so it terminate before reading the next command line, whereas in asynchronous execution it reads the next command line and executes without waiting for prior command to terminate. Then commands to execute asynchronously are set to execute in background. For example, suppose you have typed a command is who. Whenever you have typed a command who, it gives the who is currently logged in that system. So it causes the system execute program stored, that is this is stored at the file slash in the file slash binary, that is slash root, then binary file, binary directory, then who. So which prints a list of people who is currently logged to the system, while who executes the shell waits to finish and then prompts the user for another command. Whenever you have typed a pwd command, so it prints current working directory. So it will goes towards the stored file in the list slash, then whatever the directory, then slash, and then that file. So whenever you have typed a who and symbol ampersand, then the system executes the program who in the background, and the shell is ready to accept another command immediately. So every process executing in Unix system has execution environment that includes a current directory, and the current directory is the process is start directory used for all path names that do not begin with the slash character. Current directory does not begin with slash character. So user may execute the shell command cd. Cd command is used for change directory or to move around the file tree, that is a change current directory. Cd command is used for change current directory. So command a cd, so command line is cd user source then uts. So this says current directory to the directory user then source then uts. So this changes command to the directory as user source uts. So for that you should type only cd dot dot, so it will go towards the root. So cd dot dot slash dot dot changes the shell's current directory to the directory that two nodes closer. Suppose present current directory is uts, and I have typed cd dot dot slash dot dot. So my current directory uts, it will change uts to source, it will goes to the previous. So closer to the root, that is a source, the component dot dot refers a parent directory of current directory. Suppose my parent current directory is uts, so parent directory of this uts is a source directory, src directory. So whenever you type dot dot, it refers the parent directory of current directory because the shell is user program, not a part of kernel. Shell is user program. It is not of a part of kernel. So it is easy to modify it and tailor it to a particular environment. So what are the building blocks primitives or basic building block functions? So as described, the philosophy of Unix system is to provide operating system basics or primitives that enables the user to write small modular programs that can be used as building blocks to build more complex programs. So Unix operating system provide the basics that enables to user to write small and modular programs that can be used building blocks to build more complex programs. So one such basic or primitive visible to shell user is the capability to redirect input output. One of the such basic visible to shell users is capability to redirect input output. Processes environmentally have access three types of files. They read from their standard input file, write to their standard output file, and write error messages to their standard error file. So there are three types of files that have to access, that is a read file through standard input, a write file to the standard input, and write errors to the standard error files. So processes executing at terminal typically use the terminal for these three files, but each may be redirected independently. Processes executing at a terminal typically use the terminal for these three files, but each may be redirected independently. So for instance, I have written a command ls. ls means list of all files in the current directory of standard output, but the command line is ls greater than output. It indicates that the standard output file called output. Suppose I want to select only output file in the current directory, then I can use ls greater than output. So similarly, you can use for the command line on mail mjb less than later. This opens the file later with its standard input and mails its contents to the user named mjb. Processes can redirect input and output simultaneously, as in, suppose command I have taken nroff dash less than document 1 greater than document 1 dot out 2 greater than errors. This is command return, where in this command the text formatter nroff needs the input file doc1. The nroff this command reads the input file doc1 and redirects to the standard output file doc1.out. Redirect towards standard output file of doc1.out and redirect the error messages to the files. So the notation greater than means redirect output file to the descriptor 2 conveys least the standard error. So the programs ls, mail or nroff we have seen. So do not know what file their standard input, standard output, and standard error will be shell recognized by the symbol less than, greater than, and two greater than, and set up standard input, output, and standard errors appropriately before executing the process. The symbols used here: less than for a standard input, greater than for a standard output, and two greater than for showing the standard errors. Similarly, for executing the files through input, output, and standard errors, use appropriate symbols before executing that processes. So second building block. Up to this, we have seen first building block. Then second building block of primitive is a pipe, a mechanism that allows a stream of data to be passed between reader and writer processes. So pipe, it is a mechanism that allows a stream of data to be passed between reader and writer processes, and processes can redirect their standard output to a pipe to be read by other processes that have redirected their standard input to come from the pipe, redirected their standard input to come from the pipe. The data that the first processes read into the pipe is the input for the second processes. Whenever you have write, whenever you have write the program in first file, it is the input for second processes. In first processes you have written whatever the code, it is input for a second processes, and second processes could also redirect their output and so on, depending on programming need, that is known as a pipelining. Whenever I want to execute a 10 processes, but 10th process is depends on ninth process, execution of ninth process, ninth process is depends on execution of eighth process, and so on. That is, whenever my first process is executes, it gives some output. That output is input of second process. By using that output, second process will execute, then it gives that output, a particular output, and it is the use input of third process, and so on. So from first process to 10th process, it is known as a pipelining. So this is second building block of the is the pipelining of Unix operating system. Then third, again the processes need not know what type of file their standard output is. They work regardless of whether their standard output of regular file is a pipe or a device. When using smaller programs as building blocks for a larger, more complex programs, the programmer uses pipe primitive and redirection of input output to integrate the pipes as a parts. Whenever whenever you are solving any complex mathematical example, then you can divide that problem into smaller parts, then solve that smaller part individually, then combine that smaller parts so that you can get a final answer. Similarly, whenever there is a complex program, programmer uses pipes, that is, programmer divides that project or programs into smaller parts as considered as a pipe, then recombine that the part so that integrate the pieces of the part so that the user can get exact solution regarding that complex program. So indeed the system tactically encourages such programming style so that new programs can work with existing program. For example, the program or command wc with option -1 counts the number minus l. The wc command with option -l, it counts number of lines in standard input file. So same wc command with minus a w, it counts number of words in a particular file. wc command with -c, it calculates number of characters in that particular file. So see, this is operating system services. The figure shows the kernel layer immediately below the layer of users. This is other application programs layer or users layer. Then kernel is inner layer. So kernel performs various primitive operations or various basic operations on the behalf of user processes to support user interface. So among the services provided kernel, there are different services of the kernel. So first service is controlling execution of processes. Controlling the execution of processes by allowing their creation, termination or suspension and communication. So first service of kernel is create a new process whenever then execute that process whether it requires a large time then it will suspend for that time then or waiting process after waiting process it will be ready then execute that process. So for this execution of process scheduling algorithms can be used such as round robin scheduling, time shared manner that is round robin, then shortest remaining time next, then shortest job first, then long term scheduler, medium term scheduler and short term scheduler. So for execution of processes kernel uses a scheduling algorithms. So process shares CPU in shared time shared manner. CPU executes processes. Kernel suspends when it is time quantum elapses. So kernel schedules another process to execute. The kernel later reschedules a suspended process. Allocating main memory for executing process, kernel allows processors to share partitions of their address space under certain conditions, but protects the private addresses space of processes from outside tampering. If the system runs low on free memory, the kernel frees memory by writing process temporarily to secondary memory called as swap device. So if kernel writes process to the swap device, the implementation of Unix system is called as swapping system. If kernel writes entire processes to swap a device, the implementation of Unix system is called as a swapping system. If it writes pages to memory to swap device, it is called as a paging system. Allocating secondary memory for efficient storage and retrieval of user data. Allocating secondary memory for efficient storage and retrieval of user data. This service constitutes the file system. The kernel allocates a secondary storage for user files, reclaims unused storage, structures the file system in a well understood manner and protect the user files from illegal access, allowing processes controlled access to peripheral devices such as terminals, tape devices, disk devices, and network devices. So such devices require or controlled access to the given by the kernel. Then kernel provides its services transparently. For example, it recognizes that the given file is a regular or it is a device file but hides the distinction from the user processes. Similarly, it formats data in a file for internal storage. but hides internal format from user processes, returning the unformatted byte stream. Finally, it offers necessary services so that user level processes can support the services they must provide while omitting services that can be implemented at user level. For example, kernel supports the services that the shell needs to act as command interpreter. It allows the shell to read terminals input to span processes dynamically, to synchronize processes execution, to create pipes, and to redirect input output. Users can construct private versions of shells to tailor their environments and their specification without affecting other users. These programs use same kernel services as a standard. So next is, what are the assumption about hardware? In this part, there are three concepts: interrupts and exceptions, processor execution levels, and memory management. So assumptions about hardware: the execution of user processes on Unix system is divided in two levels, user and kernel level. When process executes a system call, execution mode of the process changes from user mode to kernel mode. The operating system executes and attempts to service the user request and returning an error code if it fails. If it successfully executes, it gives the service as per request, but it gives error if it fails. Even if the user makes no explicit request for operating system services, the operating system still does not bookkeeping operations that relate on the user process, handling interrupts, scheduling processes, managing memory, and so on. There are so different operations on operating system services. So many machine architectures and their operating systems support more levels than two outlined, but the two modes, user and kernel, are sufficient for Unix operating system. There are two user modes, kernel and user modes. Then what is the difference between these two modes, user mode and kernel mode? What is the difference? So processes in user mode can access their own instruction. Processes in user mode access their own instructions and data, but not kernel instructions and data. So processes in kernel mode, however, can access kernel and user addresses. Processes in kernel mode, however, can access kernel and user accesses. For example, virtual addresses space of a process may be divided between addresses that are accessible only in kernel mode and addresses that are accessible either in mode. That means it can be either accessible either in kernel mode or user mode. Then some machine instructions are privileged and result in error when executed in user mode. For example, a machine may contain an instruction that manipulate process status register. Processor status register. Processes executing in user mode should not have
these capability. These are the differences between user mode and kernel mode. Then put simply hardware view. In the view of hardware, the word term of kernel mode and user mode and does not distinguish among many users executing programs of these modes. See, there is a figure. There are two modes, user mode and kernel modes, and there are four processes A, B, C, D on horizontal axis, and vertically two modes, kernel mode and user mode. So this KK indicates in box indicates that's kernel mode, whereas UU indicates that the user mode. So operating system keeps the internal records to distinguish many processes executing on the system at same time. So although system executes in one of two modes, kernel runs on the behalf of user process, and kernel is not a separate set of processes that run in parallel to user processes. Kernel is not a separate set of processes that run in parallel to the user processes, but it is a part of each process, each user process. So ensuring text will be frequently referred to kernel allocating resources or the kernel doing various operations. But what is mean that the process executing in kernel mode allocates the resources or does the various operations. For example, the shell reads user terminal input via a system call. The shell reads user terminal input via a system call. The kernel executing on the behalf of shell processes controls the operations of the terminal and returns typed character to the shell. The The shell then executes in user mode, interprets the character stream typed by the user, does not specify set of actions, which may require invocation of other system calls. So, interruptions, interrupts and exceptions. So, first point is interrupts and exceptions. The Unix system allows devices such as input and output peripherals. The Unix system allows devices such as input and output peripherals or system clock to interrupt the CPU asynchronously. On receive of the interrupt, kernel saves its current context. On receipt of the interrupt, kernel saves its current context that determines the cause of interrupt and the services to the interrupt. After the kernel services the interrupt, it restores its interrupted context and proceed as if nothing had happened. The hardware usually prioritized The hardware usually prioritizes devices according to order that interrupts should be handled. When the kernel services an interrupt, it blocks out lower priority interrupts but services higher priority interrupts. As an execution or exception condition refers to unexpected events caused by process. An exception condition refers to unexpected events caused by process such as addressing illegal memory, executing privileged instructions, dividing by zero, and so on. There are many unexpected events. So They are distinct from interrupts, which are caused by events that are external to a process. Exception happen in the middle of execution of instruction, and the system attempts to restart the instruction after handling the exception. So interrupts are considered to happen between execution of two instructions. The system continues with the next instruction after servicing interrupts. So the Unix system uses one mechanism to handle interrupts and exception conditions. So processor execution level, the kernel must sometimes prevent occurrence of interrupts. The kernel must sometimes prevent the occurrence of interrupts during critical activity, which could result in co- corrupt data if interrupts were allowed. For instance, kernel may not want to receive a disk interrupt while manipulating linked list because handling the interrupt could corrupt the pointers. Computers typically have a set of privileged instructions that set the processor execution level in the processor status word. Setting the processor execution level, certain values masks the interrupts from that level and lower levels, allowing only higher level interrupts. So this is figure for processor execution levels. There are two types of priority: high priority and low priority. So below the network devices, that is terminals and software interrupts, these have a low priority, whereas network devices, disk, clock, machine errors, these have higher priorities. If kernel masks out disk interrupts, all interrupts except for clock interrupts and machine interrupts. Suppose in this figure there is a disk interrupt, so all interrupts except clock and machine error interrupts are prevented. Below this below this, suppose there is a disk interrupt happened, then network devices, terminal and software interrupts are prevented, whereas these are not prevented. If the mask of out software interrupts, all other interrupts may occur. If there is software interrupt, then all interrupts happen, but kernel mask out only a particular interrupt, then low priority devices are prevented, whereas higher priority devices has not prevented. Then what is the memory management? The kernel permanently resides in main memory, as does currently executing processes or as a part of it. When compiling a program, the compiler generates a set of addresses in the program that represent addresses of variables and data structures or addresses of instructions such as functions. The compiler generates the addresses for virtual machines as if no other programs will execute simultaneously on the physical machine. When the program is to run on machine, the kernel allocates a space in main memory for it, but the virtual addresses generated by compiler need not be identical to the physical addresses that they occupy in the machine. So kernel coordinates with the machine hardware to set up the virtual to the physical address translation that maps to the compiler generated addresses to the physical machine addresses. The mapping depends on the capabilities of the machine hardware and the part of Unix system that deals with them are therefore machine independent. This is the introductory part of the Unix operating system.